slides. So what we know so far about React is that we develop components, and a component is just a function in one sense. That's all it is. But it returns JSX, and the JSX is our way of describing the UI of that component. Oddly enough, we never call a React component function in the way that you normally call functions. The way we actually call them, if you like, is by wrapping them in like kind of HTML angle brackets. Because really, as I said the last day, you could think of React components as being a way of extending your HTML syntax. Right, so that's all we know so far about components, and it's all about components, but our components so far have been purely static. So that needs to change, and I'm going to illustrate some of the additional kind of syntax of and features of components by way of these samples. Now, some of you have actually already stepped through the lab that these samples are coming from, and that's okay. So, the samples, just to be sure, the samples that I'm going to step through are coming from the archive that the zip that you download with this lab. And when you download it and unzip it and import it into VS Code, this is what you have. And as always with any JavaScript project, you run an npm install first. Okay, I should have checked. People are hearing me.
Yeah.
Yeah. Okay. Yeah. Okay. So the first thing we want to do is to find out how can we actually embed variables, although it's actually a little bit more than just variables. How can we embed any kind of expression inside our JSX? And the answer is you just wrap the variable or the expression in curly braces. So on the screenshot, you can see the example. Here I've got just my component. I've declared two variables, an array and a string. And down here then, within my JSX, anywhere I put curly braces, what React does is it evaluates what's inside the curly braces. So I've got them there and I've got them here as well. So what I said there is it evaluates what's inside the curly braces, and the result of that evaluation is what is displayed on the screen from that component. So in these examples here, it's straightforward. I'm just indexing into my array of languages that I've defined up here. So it'll display Go, Julia, and Kotlin. Here, just by way of illustrating the fact that you can put anything within these curly braces, I'm actually using string templating, JavaScript string templating. So it constructs this string first. This is just normal string templating syntax here, which happens to use the curly brace as well. But so it evaluates that entire expression and sticks the result in the header. And you can have anything in here, as I said. You could call a function, and whatever the function returns, that's what's included in the UI for that component. So it's very flexible. I won't bother looking at the example because really that's all it is. Next, well, before I go next, if I go back, the problem with this component here is the array of languages and the header are internal to it. So it's completely unreusable. It would be nice if I could pass the array of languages into the component and the string, and then it's more flexible. So that brings us on to reusability. And always really with programming reusability is really an indicator of parameterization. So how do we pass parameters into our component? Well, seeing as the component is a function, it's obviously going to be via some parameters that you pass to the React component function itself. So there's in the React world, we refer to the parameters that you pass into a component, or the React documentation does. It refers to them as props, which I presume is short for properties. So a component's properties or attributes or parameters. Two things. A, how do we pass the props into a component? And number two, then how does a component access those props internally? And so I'm kind of illustrating here. The way you pass parameters or props into a component is using this syntax here. So this is kind of key value pair stuff again. Whatever the prop name is, the value of that prop, of course, the value now has to be wrapped in parentheses. That's another kind of mistake, early mistake that you might make. Otherwise, if you take out the parentheses, then it is literally, well, you probably get an error actually, rather than anything, but so it needs to evaluate, because anything, there can be anything in here. It could be a hard-coded value, could be just a variable reference, could be an expression, could be anything at all really. That's evaluated, and that becomes the value associated with this key. And then you just chain on your key value pairs depending on how many props or parameters the component is expecting. So it's key value pair stuff. What the React runtime does is it takes all of these and it constructs a special object, which we call the props object. And that props object is what you pass into your component function declaration. You can call it anything, but the convention is to call it props. So this now is an object that has been created by the React runtime. And in this simple example, this object is going to have two key value pairs, these being the two keys and the values being whatever they are. So it is an object, and so we use ordinary JavaScript object dot notation to extract the value for a particular prop within the component. Yeah. Turns out now that this props object, it will actually have other key value pairs that React runtime adds on to it, and they will become useful later on. But for now, it certainly contains our two props as well as others, as I said. Very important point here, these props are immutable. They cannot be modified within the component. There's a very good reason for that, but that's a statement of fact. You cannot go inside in this component. You can't go props dot prop one name equals something else. I think you get a runtime error, and the reassignment just won't work. So that's really why I'm assigning it const. It's more indicative of the fact that P1 can't be changed. So they're immutable, and what else am I saying? Part of the, well, yeah, this becomes part of your design process when you're designing components, kind of deciding what props should this component have based on whatever the purpose of the component is. So I suppose we look at sample 3. Sample 3. And I suppose we should look at the story first, though, because you can tell, I suppose, if you examine the code as to what kind of props it uses, but it's better to look at the story to get an indication of the props that are passed in. So sample 3. So it looks like I'm just passing in a list. Where is list? List is defined up there. Okay, there's my list of languages again. And I'm passing in a string, I think, is it? Yeah, a string as well. Okay, and I've called them this and this. You can call them anything you want to, but obviously that the names you give them is important within the component. So languages and heading, and inside my component, I am accessing languages, props.languages and props.heading again. Okay, any questions about that? No, the rendering is, do I have the, oh yeah, sample 3. The rendering is like that. So that's parameterization. So that opens up a lot for us, really, this ability to make your components reusable. Just one or two quick asides before we can talk about the next example. We know this really from before, but I'm just kind of reminding you, these arrow functions syntax, you can strip away a lot of the syntax of an arrow function in special cases. You know, if the body of the arrow function only has one statement, then you don't need the curly braces around the body. If that one statement is its return value, you can drop the return keyword. If the arrow function only takes one parameter, then you can drop the parentheses, all that kind of stuff. So by way of example, you know, this arrow function can be scaled down to this. You may find yourself really writing it like this initially because it takes a bit of experience before you naturally start thinking this way. Although, you know, it would be nice if when you write it like that, you suddenly realize, actually, I can scale this down to one-liner. Anyway, so that's the kind of shorthand version for arrow functions, which we talked about before. The second reminder is this array map method. The map method takes your source array and it generates an output array from it. And the output array elements are dictated by the callback function that you call to map or that you pass to map. Okay. Again, that's fairly fresh in our memory, hopefully. Number 3 is, you see, you can actually assign a JSX, although that's just ordinary HTML there, but you can assign JSX snippet to a variable. That assignment statement is acceptable within a React component. Now, how is that? Well, it goes back to this react.createElement method that I was talking about way back in the very first lecture when we were writing kind of raw React code before we ever talked about component. Because really, when this gets transpiled, it gets transpiled into React.createElement, and these are nested invocations of React.createElement inside this outer one. And React.createElement, we don't really know exactly the nature of what it returns. We don't care, but it returns a single thing. And that single thing is what's being assigned to the demo variable there. Okay, so those 3 things are leading up to the next feature, which we actually use quite a lot. What if we actually want to generate an array of React elements or React snippets? The typical kind of use case is a prop that's passed into a component is an array. We don't really care about the details. It could be an array of values, an array of objects, doesn't really matter. It's an array. And one of the things that the receiving component wants to do is take that array and generate a JSX snippet for each element in the array. So it wants to iterate over the array and produce an output array using map, where the elements of the output array will be JSX snippets. We'll see this being used an awful lot really throughout the rest of this module. So this is kind of the 101 example of it. And it turns out what the sample that we're going to look at, what it wants to generate is an array of Li elements. Okay. So sample 4. Again, it's probably beneficial to look at the story first. So again, I've got this component and I'm passing it in frameworks, which is defined at the top. It's an array of objects. So we'll just glance at it in a second, and I'm passing it in a string. So this best frameworks is this array of objects here. And what did we say in the slide? So what the component that's passed in this array, what it wants to generate is this array of Li elements, okay, with the name of the framework and the hyperlink to the framework's homepage, something like that, I think. Let's see what it generates actually. Yeah, so, you know, these are hyperlinks. We don't even follow them. Okay, the actual component, sample 4. So here we go. Props.frameworks is an array, and we're mapping over it. And we know that a callback function takes, well, it takes actually 4 arguments, but we only need 2. So f is going to be assigned to one of the objects in this frameworks array. So it'll be one of my objects with the framework name and the URL of its homepage and the index position of it. And it's returning actually this. So the array list here is going to be an array of these things. And that kind of works because, you know, I can assign this to a variable. So equally, I can put that into an array. It can be an element in the array. It's kind of unusual now, but you get used to it. So list is an array of Li elements. And in the body then of my component, what you can do is you can just, well, because list is an array of Li elements, it would make sense that I wrap it in a UL element. Okay, and voila, I get what the component rendered, which is, you know, that. Any questions about that, I wonder? I could have, I don't need that. This now isn't really that important, but I don't need that, and I don't need that. And, well, oh yeah, that's about it, I think. Is that going to crash me? Maybe I shouldn't have played with it. Yikes, I may have crashed it. No, still happy. Okay, that's it. So that little kind of pattern, if you like, of mapping over, that pattern of mapping over an array and producing JSX snippets and putting them into an array and then rendering that array, that pattern we use quite a lot. I'll talk about this little thing in a second, actually. You wouldn't have seen those before, but that's that. Component collections or iteration. Oh yeah, just by the way, the comment here, this will become very useful to you really when you're kind of debugging, but if I open up the developer tools, there's lots of really nice things in the developer tools, but one of the nice things is if you click on this here, and then point at a particular part of what's being displayed and click on it, and it'll bring you to exactly the part of the DOM really, but the HTML corresponding to that. And there indeed I have, I have an array of LI elements inside my UL. So this here is what was generated by the component that we looked at there. And this is what was generated by the mapping over the props array of frameworks that was passed into it. That's quite a useful little trick really to know about. So you need to click on this first, and then click on the particular part of the page, or find the part of the page that you're interested in. Click on it, and it'll bring you directly to. I did something. It'll bring you directly to. I did something stupid there, and I actually clicked on the hyperlink. But okay, that's that anyway. That's just by the way. A component returns JSX. And so all of these examples are valid examples of what a component might return. Okay, one isn't really that useful. Two, it turns out that a component can return as part of its JSX another component. And we see that a lot, or we will see that a lot. Number three, if you have a multi-line JSX that a component returns, you've got to wrap it in parentheses to help the transpiler kind of do its thing. The next point is that a component can only return one element. If you try and return more than one, then you will get a runtime error. So the example that I have here, you see, it's actually trying to return a H1 and a UL. That's two elements. And it's going to throw, the fact that I'm wrapping it in parentheses is no good. It's going to throw a runtime error. And again, kind of the explanation as to why that won't work, that even though you don't necessarily have to work back to the explanation, but the explanation is because, as we know, all of this gets transpiled into invocations of React.createElement. So really what we have here are two invocations of React.createElement. They're not nested, they're independent. So we're trying to return two things. And in any aspect of programming, you can't return two things from a function or a method. You can only return one thing. Whereas here we're returning one thing. We're returning a div that's going to be converted into React.createElement, and these are going to be nested inside it. So that's all going to work fine, but that one isn't. And so what's the solution? Well, the solution is easy enough, right? You just wrap the whole lot in a div, and you're done. That I think this is the actual error that you'll see. You see this error in the developer console. Now, that solution though of wrap it in the div, that was the solution in the early days of React. But of course, what it meant was if you had a very complex React application where you've got lots of components nested inside other components, very deep nesting, then it meant that you had all of these divs kind of were unnecessary, and the divs were actually contributing to the depth of your DOM data structure. And the deeper the nesting of your DOM data structure, that impacted on the browser's performance in terms of how quickly it refreshed and repainted your screen. Okay, so that was one of the issues in the early days of React. That was one of the performance problems with React. When we actually looked at the raw HTML that was being generated by the React app, and believe me now, the React app would contain quite deep nesting of components. I'll talk about nesting of components in a while, but it really meant that the upshot was anyway that because of these extra divs that you had to include in your components, it contributed to a very heavy DOM data structure, which is the point I'm making there at the bottom. And the React engineers solved that problem, and their solution was this special little tag, which you saw there a while ago in the example. So this really plays the same function as the div, but when you look at the raw HTML using the developer tools, as I did there a while ago, you won't see this special element. It has a name, but I've forgotten what the name is. You won't see it actually in the DOM at all. And so that solved that problem. And its corresponding closing element is this guy here. So don't do that. Do this instead. So every React application that was ever developed, it is going to be, from a design point of view, it is going to be a hierarchy of components. There is going to be a component at the top. It's going to have children. Those children will have their own child components, and so on down along. It won't be a balanced kind of hierarchy, but that's the way it turns out. And we'll see later on how we come up with a hierarchy for a particular kind of UI layout. That'll come later on down the line, but as a statement, that's actually the case. We refer, oh yeah, so you have nesting of components inside other components, or you have children. We talk about the component having children. And by way of illustration, and if I just look at the UI first of what this sample 5 does. So sample 5, as we'll see now, is going to be made up of 3 components, which I've just numbered there as 1, 2, 3. Now 2 and 3, I'm actually reusing from earlier samples, sample 3 and 4, I think. And the component numbered 1 is going to be, that's going to be at the top of my hierarchy, and it's going to have 2 children. And this idea of the way I've boxed off the UI there, that's actually going to be part of the design process, as you'll see later on. And this idea of having boxes inside boxes. So kind of another way of interpreting what those boxes are telling me now is that I'm going to have a component that is just going to be responsible for rendering what's inside box 2. I'm going to have another component that is just going to be responsible for rendering inside what's inside box 3. And I'm going to have a third component number 1, and it's actually going to, within its JSX, it's going to be using 2 and 3. But it's going to be a hierarchy. So in terms of the code, sample 5. The story isn't that interesting, but let's look at it, I suppose. Sample 5. So it's kind of the same old stuff, really. So, okay, I've got this data structure that's kind of involved, okay? And it looks like I'm passing that entire data structure down to my component as a prop. Okay, so it's got 2 inner objects, and they both have a string and an array. Yeah, okay, well, best frameworks, again, is defined at the top. And languages is our list, sorry, is also defined at the top, I think. Yeah, it's just an array. The interesting part, though, I suppose, is really this guy. This is the component that's being used by that story. And you can look at the detail later on. I'm not going to step through it because, in a sense, you can work it out yourself. There isn't really a whole lot new other than to say, look here, I'm actually importing 2 other components, which I've decided to call that and that. And here I'm using those components as part of the JSX of this outer component. So this is the component that's going to be at the top of my hierarchy. And these I would call two children of my demo component. Yeah. And so, you can just visualize it. Demo is at the top and its two children are web frameworks and languages. Right. And it is what I am calling a hierarchy. Another kind of, by the way, you'll notice in all of my components, the component is called demo in all of the samples. I think I mentioned this the last day, but each of the components are called demo. And here I'm using the component from the 04 file and the 03 file. And inside the 04 file, the component is declared with the name demo. But when I import it, I can actually give it a different name. It wouldn't be that normal. Normally, what you export is the same as what you import, but you're free to give it a different name. The only reason I called every component demo was just to make life a little bit easier for myself, and also in the way that I just wrote the lab. Okay, any questions about that sample? Right, that's component hierarchy. That summarizes this set of slides, and I'm not going to talk through the summary. Now, there are 1, 2 other little things. You don't have this slide now. I meant to upload it to the website, but I checked out what I go and I don't think I have, so I'll do it after this class. There are just 1 or 2 little aspects of ES6 syntax that we need to know about in order to make sense of the next topic that I want to cover, if you like. Like we by no means have we covered all of the syntax of ES6. So I'm just going to cover additional bits as I need them as we work our way through this course. So the first thing I want to talk about is modularity. Although, you've been using modularity and in all of the samples that I've looked at, certainly in the samples that we've been looking at just there now, that they're all using modularity, but just to cover it formally. Modularity is all about breaking up the code within your application into individual files, which we call modules. And why do we do that? Well, we do that for reusability purposes, to help other people understand our code. It would be terrible if all of our code was physically inside one file. It would be a nightmare to try and understand. So break it up into individual files is a good idea. And maintainability, if other people have to maintain our code, it's a little bit easier if we've broken it up into individual files. So we know all about this stuff, modularity, from other languages. Before ES6, modularity was supported, but it wasn't native to the language. You actually had to use a third-party library. And you will actually see that third-party library being used at the latter end of this module. Turns out that some of the node programming that you will do will have to use the old style modularity, but that's for another day. In the ES6 syntax, modularity is kind of built into the modern day syntax. And that's what I'll be using for all of my React stuff. So with ES6 style modularity, there are 2 types. There's what I call named exports and default exports, and just by way of illustration. So let's supposing I've got this file called lib.js, and I have a definition or declaration of a function, and I want to make that function available to other parts of my application. So I export it, and because it's the only thing within this file that I want to make available to other parts of my application, I am declaring it as the default export for this file. I've got another file, and here it is importing the function. In the import statement, the things to note are you've got to specify the relative path name of the file containing the thing that you're importing. So I'm assuming that bar.js and lib.js are in the same physical folder, but if they're not, then you would adjust this accordingly. But it is a relative path name that's significant of the file. You don't need to add on the .js extension. And also, I mean, the thing that I'm exporting here is essentially just an anonymous function. I haven't given it a name, so you can give it any name you want to in the import. And even if I did give it a name here, as long as it was the default export, I could still call it something else. And then I'm invoking it to do whatever. So that's what are called default exports in ES6 syntax. Named exports on the right is where you have got a file and you want to export a number of declarations within the file, and they can be of different types. So it looks like I'm exporting a variable and a constant and a function and a class as well. But these things that I'm exporting, they have to be named things. I couldn't have an anonymous function here now as something that I'm exporting. I am exporting a function, but it's a named function. And in my export statement, I can't use the keyword default because that won't work. Okay, so that's the file that's doing the exporting. And then in the import side, you've got to wrap the import in parentheses again. Now, you don't have to import everything. So it looks like that inside in bar.js, I'm only interested in the function and in the string. I'm only interested in certain parts of what are being exported. And the name that you use here has to correspond to the name of the thing up here. So you do have to know about the internals of lib.js when you're developing bar.js. Now, it turns out, right, that you can actually have a mixture of these two. We will see it later on, but I'm not going to illustrate it. But you can have a mixture of named and default exports. And when you do, then how you import them, the syntax just looks slightly different. I'll mention it when we come across it. In both of these examples, the things that are being imported are artifacts that are part of my code base. I've written them. But quite often what you'll be importing are third-party modules. Third-party modules. So for example, in all of our sample code so far, we have been importing from the React third-party module. And the only thing I want to highlight here is that when you're importing something from a third-party module, in the from part of the import statement, you just name the module that you're importing from. It's not a path name here, unlike up here. Now, it turns out that the React module actually, it looks like it has a default export, but it turns out that later on, we'll see that it has a mixture of a default export and also some named exports. But the only thing I want to highlight is don't use a path name here. You must use a path name here. That's modularity in one slide. Destructuring. Destructuring is where you have got a collection structure, and there are two types of collection structures in JavaScript arrays and objects, and you want to extract the individual elements within that structure and assign them to variables. Now, ES6, so in a sense, we want to destructure the collection. ES6 gives us a nice declarative syntax for doing that. And that's what I just want to briefly give you examples of. So here we go. So this is old style, right? I've got an array, and here I'm extracting the individual elements and I'm assigning them to variables. So this is pre-ES6. This is how we would do destructuring. This is how we do it in ES6 though. So I've got my array again, and see here, I'm assigning 3 variables and I'm wrapping them in a square brackets. That's important because the thing on the right is an array. And so what this entire expression will do is it will do a number of things. It will declare a variable called v1 and it will assign it 10. It will declare a variable v2 and assign it that, and it will declare v3 and assign it that. So in other words, this one statement here is the equivalent of these 3. this is a more declarative statement of what you want to do. Sometimes you're not interested in picking out each element of the array, you're only interested in certain ones. So that's what I'm illustrating here. So it looks like in this statement, I'm only interested in the second element, i.e. index 1, and I'm interested in the last element, which happens to be index 4 and happens to be the fifth element. So again, what this statement will do is it'll declare two variables, v2 and v5, and it'll assign v2 the value 11 and v5 the value 14. Oh yeah, even though there are more elements that, sorry. Yeah, even though there are more elements after v5, like, you know, this, it doesn't care. It doesn't have to be the last element. I think I misled you there. I said this was the last element. It's not. I mean, obviously the commas tell you what's the distance between v5 and v2 in terms of elements. So this is this destructuring syntax for arrays. Very important now that it's square brackets that I'm using here. You can do something similar for objects. And again, I'm showing you the pre-ES6 approach. So this is the pre-ES6 approach. Here's my object, and I'm extracting both parts of it. So alpha is going to be assigned the number 100, as you know, and beta will be assigned the string enterprise. So instead of writing it this way, you can do it like this. So now, note these are curly braces. So what line, I think this pen is kind of annoying me, but what line 39 will do is it will declare two variables, alpha and beta, and it'll essentially do the same as what's being done up here, right? Okay, let's not overdo it. Here's another example. In this example, really all I'm showing you is that it doesn't really matter what order you put these in, because we know that an object is not an ordered collection. So what it does here, just to be absolutely sure now, so it looks like that these variables here have to match the key names. Although, as we'll see in a second, you don't have to do that. But for now, that looks like a constraint, that the variable names have to match the key names. And that's what helps the runtime to work out, what should I assign this new variable beta? What should I assign to it? Console.log, and it confirms what they will be assigned. Now, over here, oh yeah, sometimes you're not interested in extracting each individual part of the object. So it looks like here, really all I'm interested in is the foo part. So what this is going to do is it'll just declare one variable foo, and it'll assign it the string bar. Down here, what I'm illustrating is if the variables that you want to declare, you don't want to give them the same name as the keys, then this is how you express it. So what this is saying is find the key inside in my object, find the key alpha, declare a new variable called num, and assign it the value associated with the key alpha. And so when we do console.log of num here, it's going to come out at 100. So this is how you kind of change the name of the variable to be something other than the corresponding key name, if that's what you want to do. And something similar is going on down here. Again, down here, it looks like I'm only interested in the foo key and the beta key. I'm not interested in the alpha key, but I do want to rename the variable to something else. That's destructuring in 2 slides. Just look at the examples, and I think it's straightforward enough, but I will be using it quite a lot in the code, you see. I'll just pause maybe in case you have a question, because I did kind of run through that. No? Okay. Just going to go on for another little bit. So everybody now is in a position to tackle both of these labs, even though I'd say a lot of you have done both of them already. But maybe you could go back and revisit them, certainly this one, and make sure that you fully understand exactly what you were doing rather than just cutting and pasting. So the next topic, I want to really delve into components in a lot more detail, because still our components are fairly restricted in terms of what we can do with them. Okay, we can pass props into them, and we know how to form a hierarchy of components. But at the end of the day, all we can do so far is generate a static web page. We can't interact with it, and we can't get that web page to change what it renders based on our interaction. In other words, we want to be able to make our web page dynamic, where a web page is comprised of a hierarchy of components. So oddly enough, Nora, even though I've associated this lab with this set of slides, you can actually do this lab now. No matter how little I might get through in this set of slides, you can start off this lab now. And this is the first in a series of 4 labs where you will be incrementally building the Movies Fan app that I illustrated or demonstrated there to you last week, I think. And when you've completed those 4 labs, that's what you will be submitting to me as your lab work, and that's what I will be marking you on. And it is very important that as you work your way through these labs, that you submit the git commit commands as you work your way through them, because I will use your git log as confirmation that you actually did work your way through them.